This is Algebra 1, Lesson 10-11, Quadratic Word Problems in Vertex form. Today's date is Wednesday, April 22nd, 4/22, 2020. Our objective today is to solve real-world problems relating to quadratics that happen to be in Vertex form. Okay, so if I have this general form, we've talked about it before, f of x, we always interpret this as kind of like the height. That might be a little bit different in terms of the future examples, but I'm going to do height because that does affect probably over half the problems that you'll see today in the word problems. The main thing to take away from what's happening over here on the right hand side is everything that happens over here is the dependent variable. It's the time, and then time gets manipulated by being squared and then multiplied by its scaling factor. Let's move on to example number 1. The power generated by an electrical circuit in watts as a function of its current, C, in amps, I guess, is modeled by this function P. So P is power. If you put in its current, it gives you its power. Okay, so what C value will produce the maximum power? So generally speaking, if you ever see a maximum or minimum time, so if you ever have a max or a minimum, max/minimum, it's talking about your vertex. Again, your vertex is given by the opposite of whatever this h is. So it's going to happen in this case at the opposite of -3. So it's going to happen at 3. But why? So the answer is c is equal to 3. This happens because the maximum happens at the vertex. It always will happen. The maximum or minimum will always happen at the vertex for these types of problems. And that's because if you look at a parabola, there's its minimum, there's its maximum. They happen at the vertex. Well, how far left and right do I move to find my vertex? Well, this inside the parentheses affects your horizontal shift. It affects what C value to choose. So that's our rationale. So, and you can try this too, to do the next question. What is the maximum power of the circuit? Well, let's do that. So if I plug in 3, what's going to happen? 3 minus 3 is 0. Why do we want this thing to be 0? Because this is going to be multiplied by a negative, which is going to take away from 90. We want this amount here to be as small as possible to take a little away from 90. And what's the smallest thing we can take away? 0. And that makes sense. So 3 minus 3, so I can write this out. This is -10 times, we're plugging in 3 from up here. Plugging in 3 minus 3 quantity squared plus 90. So I've basically rewritten the right-hand side over here, but plugged in 3, which was from our first question. And then when we do that, we get 3 minus 3, which is 0. 0 squared is 0. 0 times -10 is 0. All of that is gone. It's 0. 0 plus 90. 0 plus 90 is just 90 watts if you're using units. And I guess if I was using units, I would say amps up here. So I can say amps, or amperes if you want to be official, and then 90 watts. I always thought watts was capitalized, but maybe it's just lowercase. But anyway, there's your answer, 390. You don't have to worry about the units for Khan Academy because it does the units for you. And what current will produce no power? This is a much harder question. No power, and again, this P of C represents power. So set this equal to 0. That's what it means to have no power. So our new equation down here will be 0 is equal to -10 times the quantity of C minus 3 quantity squared plus 90. So I need to figure out what C value here will give me 0 power, and it's essentially just solving this thing. We've done this before. The first step is to subtract 90 on both sides. So -90 is equal to -10 times the quantity of C minus 3 squared. And then I'm kind of skipping steps. I think you guys can see that I clearly subtracted 90 from both sides. From here, I'm going to divide both sides by 10. In fact, I think sometimes on Khan Academy they say what they're doing over here on the right hand side. I wonder if that's quicker notation. What we did was we divided both sides by 90, and then our next step is, wait, did I really just say divide both sides by 90? Subtract 90 on both sides, so I should have said minus 90, and make sure it's really far off to the right so you're not confusing that for anything in the equation. That's what I'm doing for my steps. I don't know if I like this new notation. I'll try it out. And then from here, I will divide both sides by -10, so divide by -10. And when I do that, I'll get +9 because negative divided by a negative is a positive, and then 90 divided by 10, you just move the decimal place. So 9 is equal to, in parentheses, C minus 3 quantity squared. And then from there, we are going to square root both sides, and I'm going to get plus or minus 3 on the left-hand side is equal to c minus 3. What we did was we took the square root of both sides. And then from there, we're going to get our final answer. Again, in blue is going to be 3 plus or minus 3. And that's from adding 3 to both sides. So our answers, let's do the minus sign first. 3 minus 3 is 0. So c could be 0. And let's do the plus sign. 3 plus 3 is 6. So c could also be 6. So at what current will produce no power? And it makes sense. If the current is 0, it's producing no power. And if the current is 6, it's producing no power. So both of those two are the answers. In Khan Academy, you enter the smaller one first. So you'd enter 0 first and then 6. And that's all the questions I have for example number 1. Let's move on to example number 2. So we have a deep water free diver. They have their altitude measured, and that can be modeled by this equation. So A is altitude, and then T is time. I didn't explain that enough in my question, but there it is. I need to figure out what the altitude of the diver is at the start of the dive. So whenever you have a start value, the start value just means plug 0 in for your independent variable. So this is our independent variable, just plug in 0. So I have, it's going to be 1/16 of 0 minus 40 quantity squared minus 100, and I'll underline the word start because that's what I'm doing. Whenever you see start, plug in 0. All right, so negative 40 squared, 40 times 40, well, 4 times 4 is 16, and then I have another 10. 10 squared is 100, so 1600. And that's still multiplied by 1/16, and then I'll subtract 100 after I do that. My next step, what's 1600 divided by 16? Oh, that's just 100. And 100 minus 100 is 0. So the answer is 0. I don't know. Does it say meters or anything in here? No, it doesn't say meters or feet. So I'm just going to say 0. 0 some unit. Next question, at what time t will the diver reach their lowest altitude? Okay, so whenever you see lowest, maximum, minimum, any word that looks similar like that, you're looking for the vertex, the x-coordinate of the vertex. So I'm just going to take the opposite of negative 40, and then the answer is 40. The vertex happens at t is equal to 40. What is the lowest altitude reached? Okay, so now plug 40 in. So our equation again up here was 1/16. So I'll write this down, 1/16, and I'm going to plug in 40. That's the 40 that's being plugged in, minus 40, and then minus 100. I forgot the squared as well. And clearly 40 minus 40 is 0. Everything over here is 0. We can just cross everything out. That's all 0, minus 100, so the answer is minus 100. So I guess one thing that we can really add to our notes at the very beginning up here is this k value should be the maximum slash minimum. Max slash minimum. Depending on if it's going up or down. If it have a negative out front or a positive out front. And finally, at what time does the diver come up to the surface? So what does that mean? That means you have to be thinking about the problem in terms of its context. So let's say that the diver starts here, he goes down, and then he comes back up. So he surfaces again. So I'm looking for when I have a height or an altitude of 0 instead of a negative value. So I'm going to say my height is 0, my altitude is 0, and that's going to equal our equation 1/16 of, was it t? I think it was t, not x. So t minus 40 quantity squared minus 100. So our answer here is going to be, I'm going to try using the same stuff that we did last time. I'm going to add 100 to both sides. I'm going to get 100. I'm adding 100 to both sides. So I have 100 is equal to 1/16 of t minus 40 squared. Next step is to multiply by 16 on both sides. So I get 1600 is equal to t minus 40 quantity squared. My next step is to square root both sides, and square root of 1600, I just happen to know that's 40 because up here we did 40 squared to get 1600. So 40 plus or minus 40, almost made that mistake. Plus or minus 40 is equal to t minus 40, and then we have to come up to our next step. Our next step is to add 40 to both sides, so 40 plus or minus 40 is equal to t. And what we did was we added 40 to both sides. And then 40 minus 40, that's when t is equal to 0, because 40 minus 4 is 0, and then the other t value is 40 plus 40. 40 plus 40 is 80. And obviously, he starts at 0, he starts diving down, so that doesn't really make sense in the context of this question. The answer is 80. So 80 seconds, minutes, whatever our time is measured in, 80 units of time later, our diver comes back up to the surface. All right, so that was a roughly 11-minute video. That concludes notes for Algebra 1 10-11. I'll see you guys tomorrow.